disconnected me. I'm on. I thought I had 3, which I ba-bum, ba-bum, ba-ba-ba-bum. Oh, that's better. Too loud? No? Good. I'm quite enthusiastic, so that might be a little bit loud. Yeah, all right, I can tap that. Okay.
Okay, fantastic. Welcome, everybody. It's good to see some new faces.
See one?
So anybody that's been to Microsoft conferences of recent years will probably know this guy. He's if you didn't catch his talk in Future Decoded, then you missed a really good talk.
Thank you.
Paul Foster, at one stage when both Andy and I met him, was the entire IoT Microsoft UK strategy. It's evolved since then, but he's been there since the formative years with things like NetMF, NetDuino. I get all the names of this hardware wrong, so correct me if I've made a mistake with it. You know, helping out the microbit strategy with all the kids teaching for the schools and things like that. So very, very immersed in the hardware side. And as you know, as things like the IoT Hub and Azure Sphere have really began to emerge as technologies, linking that sort of cloud and IoT platform. I think Paul's had a lot of exposure to these kind of things with customers. We're not going to hear about this tonight, maybe a little bit, but we're going to hear about this fantastic citizen science project that Paul's involved in Norfolk and Suffolk. But I just want to give a small introduction and take the stage.
Thank you very much, Richard. Good evening, everyone. I'm going to be my normal sort of bouncy self, so if it gets too loud, the guys will deal with it as I talk through. So from my perspective, I've got a couple of jobs to do this evening. First one is to get you excited about the opportunity that now presents us in terms of IoT and the opportunity across the UK, the opportunity to help society, the opportunity to contribute to some of the biggest challenges that we have in our society today, and to ride this wave, this enormous wave of IoT. And I'm going to turn that down, I think, because it's killing me. Is that better for you? Yeah. Okay. If it gets to what have you, shout at me or wave at me. I want to tell you, first of all, the story of Norfolk and the TTN network, the Things network that we created or utilized in Norfolk. And I want to tell you about, how that's now developed and what it's now contributing, and why I started that engagement in Norfolk. Before I do that, I'm just going to ask Mark to just wave his hand. Mark Stanley. So Mark is a fellow TTN person, but is based in Reading and Berkshire and so on. So if you're in that area, you can join this community of the Things Network there and get involved. And if you're not there, there are plenty of other TTN communities all over the country. And if there isn't one in your area, then by all means, start one. It's extremely easy, as you'll find out what that really means. So, as Richard alluded, actually, this is my 25th year at Microsoft. So I've been around a lot, thank you. and it's actually my 50th year of being on the planet. So there you go, half my life I've been at Microsoft. And so I've been involved in a wide variety of things, some that have flown, some that have not. But never mind, Windows Phone, I loved it. And anyway, in all of that work, IoT has been a core thing for me because I think it's a core thing for us, in geekery, in that, a bit of hardware, running our software, connecting to somewhere else by wires or without wires. Nothing's more fantastic than to see your end-to-end system actually work and flow. And when I first started writing code way back in the last millennium, I was involved in a suite production line for Roundtree Macintosh, and I was actually running on IBM PCs on a first 9 tiles network, which is one of the first PC LANs of that era, and we were instrumenting these chocolate vats and storage tanks and Easter egg making machines and all this sort of stuff. So I've always had a bit of hardware along with my software, but I am very much a hobbyist electronic guy, so I don't have any sort of formal education in it. But that interest has taken me through this journey. And a number of years ago, I was working with social housing, and we were looking to try and address a number of things, predominantly fuel poverty, and our ability to not only identify it, but of course, therefore, take an action to help resolve it. And we were working with a number of social housing organisations and HACT, the Housing Associations Charitable Trust, which are just over at Old Street. And we were building out Wi-Fi networks in volunteers' houses to understand how they were heating their home and whether there were inefficiencies that could be addressed. And it was really hard because of the Wi-Fi connectivity, the dependency on a broadband and the security elements of that broadband and the amount of effort that had to go in to configure the devices so they could connect to that Wi-Fi. It was all, far harder than it needed to be. And also in that same time, Microsoft Consulting Services were working with a number of county councils. And the sort of information that was coming out of those projects was really disturbing. The implications, or the impact, I should say, on people's lives through the poor delivery of service or the poor timing of service was just shocking. And I have a scenario that hopefully doesn't resonate with many of you, but it's worth being aware. We were working with Kent County Council, and we were working with one of their service providers, a small privately owned service provider. And in working with them, we were analysing their data and the outcomes of their data, and they identified themselves and volunteered it in terms of making it public, that they were aware that if they delivered their put-to-bed service too early for an elderly person, what happened was that the recipient of that service would stop drinking fluid some time before the put-to-bed service. And they did that because they didn't want to wet the bed, okay, and have an accident overnight. So if the service was done too early, they stopped drinking water or fluid sometime really early on in the day. And then they wouldn't drink anything again until they were, had the get-up service the following morning. The net result was this was a downward spiral of dehydration that usually resulted in a urinary tract infection. And at that point where it was actually caught, it usually resulted in the individual having a hospital stay, which is actually quite expensive and might typically have taken, 5 to 10 days to resolve the problem. At which point, there became another fact, which was there was a social services, engagement at that point where the discussion went something like, are you able to look after yourself now? Maybe we should be looking at putting you into some form of home. So the simple fact was the poor delivery of a service had a huge impact on a person's life and potentially, removing their ability to live an independent life in their own home. And that was so absolutely shocking that, we were working very hard to try and come up with a white box of goods that people like you and I that have a reasonable amount of money could actually buy for our, parents, our relatives or others, so we could instrument and understand what was happening and be able to ensure that service delivery was going well and also ensure that these people were, living well. So extending their ability to live an independent life in their own home rather than having the negative effect. And all of that was terribly, exciting and highly justified, and there's lots of energy for it, but it was hard because of the dependency of connectivity. And then a few years ago, this suddenly started to change with the development of a technology called Lorawan, which is a low-powered wide area network. And now we're in a really exciting position where not only is it inexpensive to set up and run a LoRaWAN-style network, but devices are inexpensive, and we're growing to a point where we could actually do that thing and deliver a box of goods that could help people live a longer independent life. So that was a lot of my motivation, and this actually came out of Barnet a borough council some years ago, and it's the classic graph of doom, which in simple terms means there's a demand in service going up, but funding is falling, okay? And this intersection was originally, expected to take place in 2020, but actually, sadly, last year we saw Nottingham County Council actually financially fail, and were only able to deliver their statutory base level of service. Okay, so we have already reached, and in some cases passed, this point of intersection where demand outstrips funding. And so the question is, what can we do to contribute to solving this problem? And what that actually leaves us is this challenge for councils of all shapes and sizes, trying to innovate their way out of this funding crisis is hard, because typically that level of innovation requires an investment, a financial investment. And trying to spend money when you don't know the success story is extremely difficult to justify when you're in this situation. So this is where, I sort of came back into this area in 2017, having been working with Lorawan in 2016 with facilities management companies looking to basically place sensors in buildings to retrofit instrumentation to them so that we could digitally transform those facilities management services. And in playing with Lorawan, it was really obvious that suddenly we had an inexpensive network technology that had large ranges and had great building penetration. So the potential was that we could start innovating those sensors that I'd wanted a few years beforehand and actually start instrumenting homes. So I did this sort of thing. This is one of the favorite quotes. It's attributed normally to Arthur Ashe Jr., who was an American athlete. But actually, if you dig a little further, I think it came from Theodore Roosevelt's biography and was attributed to some landed gentry giving them some advice. What can you do? Well, start where you are, use what you have, and do what you can. This was me in sort of early 2017, where I suddenly realized I could buy these Lorawan gateways. In fact, I could make Lorawan gateways. And I made a couple, and I was talking about it at various events in Norfolk, where I live. And a Norfolk sort of connector said, you need to get the councils all in the room. And before I knew what was happening, he'd got all the councils in a room with me in front of them. And I said there, and I said, you know what? I'm covering Norwich with a Lorawan network. And you can't stop me. I don't need your money. But I do think that if I create a community, we can innovate on your challenges and demonstrate the value of such a network and how it could help you in this funding crisis. And they all were very interested, and they all committed to, if I could prove it, they'd provide maybe some additional gateways. And basically, a year later, we went back to them and showed a number of test use cases that we created that they had defined the challenges for, and showed them running over our local network. And the reality is, that our current time in technology has never been more accessible. I think we say this every year, but the reality is it's fascinatingly more accessible. I mean, there's tremendous range of programming environments, which means that you can very simply create from visuals or through hard, real coding, as I might say, to write stuff. But then hardware, look at the world of Arduino. Look at the Adafruit Circuit Playground. Look at all of these other styles of hardware, services that are out there for the hobbyist. The ability to actually create a thing and start programming it is supported by these broad communities that are actually global communities. So if you want to connect a sensor to, your Arduino, you can guarantee almost that somebody has already done it. So there'll be a blog post, a tutorial, a supporting library, something that will help you get going. Okay, it's just incredible that that is there. But the missing bit was always this, the connectivity, as I've described. Now, some of the frustration for me has been up here in this our cellular mobile world. Some of the work I did way back. Anybody remember Stinger and the first Microsoft smartphones? Oh, you see, you all look relatively old, but you're not as old as I am, clearly. So basically, you know, our first wave of connected pocket PC and things like that, I was in the team bringing the XDA to the UK, which was the first GSM connected pocket PC. And beyond that came Stinger, which was our smartphone, which we launched with Orange, and a whole variety of things. That basically meant I spent a lot of time working with Vodafone and Orange. And, you know, it was amazing because I was inside their security firewall. So you could do all sorts of interesting things. If you knew a Vodafone number, you could track it across the city. You know, it wasn't a problem. You know, it was just available for you to see where they were popping up in the operation of the network because it was just operational data. So we could quite literally follow colleagues that would disappear down into one tube station and pop up at another one. And basically, there was this whole wealth of information. But we were in this standoff because none of the carriers knew how to commercialize it. And although we offered ideas, you know, they didn't want to give Microsoft the opportunity to commercialize it in case we gave them the edge and we made more money than they did. So we're in this thing that couldn't go anywhere. Very frustrating. I went off and did some other stuff in Microsoft, and of course I came back, as I mentioned, with Windows Phone to find, of course, you know, devices have evolved, they've all got GPS in them, lots of other connectivity, great bandwidth, but that network of information just wasn't there. It wasn't still being utilized properly. So who's heard of reality mining? Nobody again. Oh, one. So reality mining is a sort of a 10-year-old MIT idea, which is quite literally, all of us are walking around with a phone, so the carriers know exactly where we are, what direction we're moving in. You know, they can probably predict what train we're going for, or if we're in a car or a bus. So they know where we're traveling to and the volumes of movement that's occurring. And it's that sort of data that's really interesting. But at the moment, it still exists behind this giant paywall that carriers put up. So if you've got enough money, you can pay for that information. And I know in Norfolk that when we have a big, you know, Norfolk show or the air show at Great Yarmouth, we have a local highways contractor that runs all the traffic lighting to speed the traffic through. They pay for this data, and their system basically looks and sees how many cars are coming down this way and that way, all based on mobile phone data. And their traffic lights are controlled by those volumes. Okay, so they're literally completely optimized. And this is the thing that, you know, it's fantastic, but it frustrates the living daylights out of me that we aren't able to make more use of this wealth of information. So, you know, although we have connectivity as an individual, we're still not making, you know, the most of this data, that what it represents and what it presents to us, because there's a commercial aspect to it. And of course, we've seen, you know, new technologies come along. LTE-M is one of the technologies in the LTE stack. It's actually quite an interesting one because in the traditional GSM world, you know, your devices have a time to warm up, connect to the network, synchronize, and that's usually sort of 30 seconds, and back in the day it was 30 seconds to a minute. Nokia always disguised it because, of course, performance is an objective thing, and if they shoved their logo up straight away and gave you a signal bar, you felt like your phone was instantly active, but you still couldn't make a call on it for 30 seconds, yeah? But LTE doesn't have that limitation, which means you can drop the stack, and then you can power the stack up, transmit, drop the stack again. So it's really interesting, because that sort of utilization of your radio, where it doesn't have to be on for a long period of time, is where we gain battery life. And that's how devices can last longer on battery. Narrowband IoT is a key thing, but for me, it's still in this space. It has this huge carrier model attached to it still, and therefore I don't favor it, because I'm still in that same cycle where there's a lot of useful potential information which I can't use, and I've got to continually pay for it monthly. Now, of course, LTE-M, I have got to do the same, but what's interesting is LTE-M is in the LTE stack, and that's part of the standard that's already out there, so you can already buy data SIMs that are only a few euros a year for limited bandwidth for devices. So it's interesting, sort of at the moment, there's a commercial push to drive this, but actually this isn't being pushed because it's already become a commodity item. So interesting. But essentially these top three suck from my point of view because we've got that carrier model on it, right? And I really want to get away from that carrier model, not least of which, just because I think we can do more than what we're doing. So then you're into the world of Wi-Fi, and as you know, we might have free hotspots, but these aren't, you know, that universal, particularly in my neck of the woods where I'm out in sunny Norfolk, you know, and, you know, what's interesting is that we might have 1 or 2 free hotspots run from Barclays in the town, as we still have a Barclays branch. But you know, other than that, there isn't really any free service. And what's also interesting up here, these things fail very rapidly. If you drive away into the countryside, away from an area of density for population, there isn't the coverage. We've been watching our network's infrastructure shrink as all the carriers try to get a little bit smarter in terms of utilizing each other's investment infrastructure, or infrastructure investment even, to the point now that if BT OpenReach fails in our area, all the carrier data services typically go offline. Yeah? And so, you know, it's hopeless in terms of, you know, I've got farmer friends who will be out in their fields and have no coverage, yet we are as flat as you get, okay? So there's no hill getting in the way of the signal. It's just that it isn't commercially viable for them to put coverage there. So it's not. So it's incredibly frustrating in these things. But then along came LoRaWAN, and this is where, you know, I got excited because this still needs a backhaul, but it is available for any one of us to, you know, stand up a LoRaWAN gateway and either connect it to a larger cloud service or run it privately. But it really is a wide area network that we can utilize under our own steam or as a movement. And I think the Things network is actually really now a movement, which is really interesting for us to go through. So let me talk about the Things network first of all, and I'll come back to some of the details on LoRaWAN. So the Things network was started by a couple of guys in Amsterdam in 2015. And it was open source, you know, open hardware. They started writing up a cloud service that could deliver and manage LoRaWAN. And people were literally buying the early LoRaWAN network concentrator boards like I did and strapping them to a Raspberry Pi. And there they ended up with an 8-channel gateway that had a theoretical utilization of several thousand devices and might even, with the right antenna, have a range of something like 12 kilometers in line of sight. You know, and it really meant that I could stick one on top of my house, and as far as I almost wanted to go running, I would have coverage of that activity. So when I built 3 of these and placed them around Norwich, being able to actually get one of them high up on the tallest building in Norwich, you know, we started to immediately see some substantial coverage, which was fantastic. So this is an open source software. You can go and pull the Things network stack down even today. You can contribute to it, and you can run it up in your own virtual machine on your own laptop, as Mark was telling me earlier this evening he's doing, just to explore and play with it, you know, and you can run it in a variety of different ways, and I'll talk about that in a little bit more detail. So they became a real, you know, force because of this whole open source approach and the fact that they had a free-to-use cloud service. Now, the little claim to fame from Microsoft's perspective is, if you know, remember BizSpark? Yeah? You know, Richard knows BizSpark, yeah? So the Things network was a BizSpark startup. So they received £120,000 of support credit from Microsoft to run their Azure stack, and that's where the Things network grew without sort of limitations until sort of April last year, where that time period then you know, fell away, and they've since done the classic startup thing of who else is going to give us money to find out where they're going to run things. But anyway, so we now got this movement offering a sort of a free for responsible use of the Things network, a LoRaWAN network. And LoRaWAN is basically, in Europe, it's a 868 megahertz radio band. So it's the ISM band, the Industry, Science and Manufacturing band. It's technically licensed as a free to use, but there are rules about how you can use it. So we have this thing called a duty cycle, which describes how often you can actually transmit over it. So there are limitations to it. But the great thing is that this has a number of different types of devices, and we call them device classes, A, B, and C. And in the most common current class A, you know, it's a case where the radio is turned off. And when you want to broadcast, you turn it on, you broadcast, and you turn it off again after a short period when you listen for a response, if there is one that you're expecting. And that's how your device basically operates. So it operates most of the time with the radio off. Okay, and hence we are able to see, you know, this incredible long battery life, which is quite literally measured in years, depending on what the sensor and the activation frequency is for your device. But we have commercial devices claiming 10-year battery life. Some of them succeed, some of those we are still waiting to see. But even in our own developments, certainly within Norfolk, we have devices that will last multiple years, on a little battery pack of a couple of treble A's in there, which is quite fantastic. And during this time, we've seen an ecosystem from the LoRa Alliance, which is essentially the standards body for LoRa and LoRaWAN, evolve to the point where there are many different professional organizations creating devices and gateways. So, really the message at the Things Network conference earlier this year in February is that, LoRaWAN is here. We've established a beachhead of business and ecosystem where people are building upon it and developing it. So this really has evolved quite significantly. This is a little while ago, but it just shows you that there's global sort of representation. Apart from in Russia, there's pretty much global representation of Things Network gateways. So within your sphere, so within the European sphere of usage, you can turn up anywhere in Europe here, and your device will work without you changing anything. It'll spin up, find a gateway if there's one there, or a gateway will receive its broadcast, and your application will work. And when you look in closer, you can see that there's quite a density, across that part of Europe, Holland, etc. But you can see also that the UK has, an interesting set of coverage working out here in Norfolk, with some elements of Suffolk around Felixstowe, but the Norfolk area here is where I've been doing my stuff. And when you look just slightly further or in a little bit more detailed, those bigger blue spheres are showing the range of a particular gateway. And this all comes from a tool we use called the TTN Mapper. You can go to ttnmapper.org, and you can actually download the TTN Mapper app to your iOS or Android phone. And what we do is we walk around with a small device. This one's got its battery and everything in there. And basically, it's just an off-the-shelf Adafruit Feather-based device, this one with an OLED on it. And I can just switch that on, run the app, and this will make a transmission, which my app will listen to from the cloud. And when it hears that, it will say, OK, I heard a transmission. This is the GPS coordinates that I had on the phone's GPS. So we end up with a mapping cycle in that regard running around. So we spend our time driving around with antennas on our car, where we can just literally, run the mobile phone app as we drive around, and we're mapping our environments to show coverage. And what's interesting just here is that on Great Yarmouth, well, let's talk about this blob here. I've got a different diagram coming up, but this is a very tall building in Norfolk, and that's 27 kilometers between that building and that one. And we have the ability to pick up sensors in Great Yarmouth using that building across 27 kilometers. What's also interesting, in the right weather conditions, and there's a sort of atmospheric advantage that you can gain with this almost piping of your radio signal through the atmosphere. But one of our community members achieved 238 kilometers by having one of his sensors in Great Yarmouth picked up by some of the gateways over here on the continent. So, it's an interesting place to play when you're in this space. So any radio hams? No? Okay, well that's interesting. Now I can get away with it. And Mark will correct me where I go wrong here. But LoRa, so there's LoRaWAN, which I've been talking about. That's, if you like, the MAC layer of the protocol stack. And then below it, we've actually got the technology that modulates our signal across the radio waves. And that's actually called LoRa, and it's LoRa modulation. So LoRa modulation uses what we call a chirp spread spectrum capability. And this is sort of best illustrated in this graph here, where you can see that the frequency alters in these things. So it's actually a chirp, an up chirp, as we call it. So the frequency increases slightly in the channel. And you can see for different periods of time, because we have varying spreading factors to cater for distance. And also to help survive interference. Because LoRa modulation and LoRaWAN isn't designed to exceed the local noise floor to make its broadcast. It's actually designed to operate below the noise floor. So we only have a sort of 14 decibel power transmission out of our radios, so pretty low stuff. But it operates successfully because of this. Now, chirp spread spectrum technology has been used, for some years in military and other sort of areas. It's very robust to interference. And the reason is that those yellow lines you see of varying pieces are just, one sort of symbol or one element being transmitted, one bit being transmitted. And as we have a longer or larger spreading factor, so this last one might be spreading factor 12 or SF12, the same data item is being transmitted in each one of those, let's say, but you can see that this is actually on the wire, as it were, on the air longer. And therefore, it has more power being put behind that transmission, and I have the ability to actually go for a longer distance, but also survive the interference that it might be having. Well, we have an interesting link budget as well. We have a link budget of somewhere around 150 decibels. Now, I think about 10 or 12 centimeters of concrete robs you of about 10 decibels or something like that. So if you've got 150 decibel link budget, it means you can pass through a number of solid objects quite happily before your signal gets lost in that transmission. So this is a slightly deeper picture, which might be more confusing, but the spreading factors we work from are 7 through to 12 in Europe. And every time you move down, you essentially double the period of time that your transmission is on the air. So that line that you saw in the previous piece, we're getting longer on the air each time. But of course, by doing that, we actually halve our data or our baud rate. So the symbol rate is equal to the bandwidth divided by 2 to the power of your spreading factor, okay? Which means that, here I could transmit something like, 12 bytes, and it'll be on air for something like 40-ish milliseconds. But by the time I get down to here, it's going to be on the air for several hundred milliseconds, okay? Now, if I'm operating as we are in this duty cycle that says you can only utilize a very small percentage of your airtime, in fact, it's 1% for most of the subbands in Europe, then you start to realize that how long you're on air is important, because that 12 bytes does mean that I can transmit hundreds of times in a day at SF7, but I might only therefore be able to transmit the same data at SF12 maybe 10 times a day, okay, because I'm using up my airtime more often. So the object of the exercise is really to have a density of gateways that keeps you in this sort of area. And then you can have this large volume of devices, and you can have a high frequency of transmissions in that support. So, as I've mentioned, I started setting this up in Norwich. And what was interesting was that without really thinking about it, I said, hey, we're going to be a community-first activity, because I said to the county councils, don't need your money. I'm going to sort of build a group of creative people like all of you, and we're going to, throw our spare time at your challenges, and we're going to have fun building electronics and running software for it. And unsurprisingly, there was a willing group of people that wanted to come and participate in doing that. But that approach, community-first approach, was different to some other councils, which I'll talk about in a minute. So we started experimenting. I started experimenting at this time. This is where I started meeting the council, and we moved forward. And in July 2017, we had our first sort of event where I got a number of people together in a room. I pre-ordered PCBs from China, and I bought the radio cards and the Arduino microcontrollers I needed. And we had a big old soldering fest, and everybody walked away with what we call our basic node, which is something that looks like that, which is basically. The green board is this thing called an RFM95W. It's an 868 implementation by Hope RF of the LoRa transceiver. And then the other one is a classic Arduino Pro Mini at 3.3 volts. And it has a power regulator on it, which means you can give it more than that, but it will feed the whole circuit 3.3. And then all the pins that are sticking out there basically mean you can stick whatever sensors you like on there and have great fun building out your Arduino-based sensor. And at the time when I did this, the power was slightly stronger, And it meant that I could build all of that and offer it at cost for £10, right? And because I'd already spent a lot of money on gateways, that's all everybody had to build. £10, and they had a device they could then go and innovate on, which was fabulous. So we did that in July, and then we supported the council, let's just go forward again, with a whole series of fun things. So this was one of my first gateways, Raspberry Pi, IC880A network concentrator for LoRa is the other board. It communicates with the serial peripheral interface, SPI or SPI, if anybody knows that. It's fairly straightforward and simple to do. In fact, one of the existing TTN groups has an entire script for deployment of the gateway software that you need. So you just run that on your Pi, and hey presto, you've got a gateway, which you can then register with the Things network. We managed, if you register a number of gateways, I think it's like 2, then you become an official community. So we very quickly became an official community because of that. And we had this great hack space where we worked, which enabled us to do soldering without too many limitations. And we started just doing fun things. So I got a commercial gateway on that tall building, not particularly well placed because the antenna is right next to this dirty great mast. So we had a blind spot, but we learnt from that. But then we did some other things. Norwich got, last year, toasted for its air quality. So I immediately went out and built a particle air quality sensor using an inexpensive Plantronics PMS 5003, which is like £13 from China, £45 if you buy it over here, but £13 from there. And it's connected to a slightly more powerful Arduino-compatible board, and the topmost board in this picture, the large silver piece up there, is a microchip RN2483A, which is a certified Lorawan radio, which just meant that it was entirely legal from a transmission perspective, or would have been if my antenna wasn't a bit of wire and was actually an antenna that it was certified with. But these things we all learn. But essentially there we had an air particle sensor that was going to cost you 40-ish pounds. Basically, and we were able to, or I was able to walk around Norwich taking air quality readings as I just wandered around, running it from a 5-volt USB charger. And then at this end of the spectrum, what was quite interesting was just where these devices were going. So obviously pound coin for scale. This is a Murata chip. It's a MCU and a radio. So from this regard, it's both of those green chips there, but now in a device that's smaller than pound coin, okay? And that meant that we were now starting to really be able to shrink things down and make things more inexpensive. And this piece, I'll give you a demonstration of later, but it's what I call an urban tracker. It enables us to actually estimate location by sniffing Wi-Fi MAC addresses and RSSI values and then shipping those back over LoRaWAN. This one's interesting. It's a 24 gigahertz sensor, which I was using for monitoring traffic. So it's sort of giving me that view of cars coming towards me in some of the scenarios we were using. And we basically built out a whole series of different examples that we supported the county council with as we went through these things. So I've spoken about some of this, but just to point out, and Richard will be able to publish the slides later for you, but this is the tutorial that exists on the TTN network site that will just take you through building this red board that I was showing. So, it's all out there and it's all public for you to connect to. And just to get a little bit more technical, these are the pieces that we're just really wiring up. Here's our Hope RF board, our Pro Mini, and essentially, we've got 4 pins that need to be connected for our comms, for the SPI, and then we've got a ground and a reset and some interrupt and power. So not a lot of stuff to wire together, really. And we've had great fun building a range of different devices. You can, of course, buy some devices. So this one that I held up earlier actually has this Adafruit Feather M0 with the LoRaWAN you're familiar with, that Hope RF board on it. They neglected to connect the interrupt, so that's the fix. A little bit of wire from pin 6 to pin 1, DIO1, and hey presto, you've got a LoRaWAN board for, off the shelf for maybe £30 or something like that. But at the other end of the spectrum, guys started wiring these boards directly onto those Pro Minis. So that is the smallest and cheapest sort of board that you could almost do. in your back room without any great soldering skill. And again, the Pro Mini is £2.50. Well, it was £2.50. It's now £3.55 when I last checked on eBay. Again, pound. And the Hope RF, if you buy it off the shelf in the UK, it will cost you £9.50. If you buy it from RS or Farnell, it'll actually be £12 or £13. And if you buy it through AliExpress, it's about £6. So, same thing, just getting, different costs on commercialization. And there's a lot of open source hardware. These are two different boards that are being built and another board being built all for the various devices. So you can quite literally go out and build these things for very, very little money. So where are we today? Well, this is a current map of our deployed gateways in Norfolk. You could optimistically call it a third or pessimistically call it about 25%. The council's focusing on the A47 and the A11 corridors. Particularly the A47 has a dueling campaign, so this technology gives them the opportunity to gather more evidence of the utilization of that road in comparison to the A11, which is already dualed. The red triangles are the next couple of gateways that are going to go up, which will start to fill in, hopefully, the area on the Norfolk-Suffolk border here and up in North Norfolk. My home one is there, and you can see I need to get it higher because it doesn't do a lot, but it covers my area. But you can see, the reach of from Norwich and our gateways in Norwich, the reach of the ones in Great Yarmouth. We have a number of gateways, which means that, we have redundancy and we have, the ability to deliver a service to a large number of devices. And this now presents us with the opportunity to offer scenarios in, on the coast, in agriculture, in transportation, in urban settings, in city centre settings, in rural settings. So if anybody wants to test an application or a scenario, Norfolk now has that broad spectrum of different places and scenarios for you to utilize and explore. And we're doing some really interesting things. So Norwich actually has a very good research park scenario, and the John Innes Centre, we have a team building a nitrate sensor. So it's an inexpensive sense probe for measuring nitrates in soil. And they actually reached out to us and said, well, our data loggers are currently £1,100 a pop. And we rocked up with a £30 Lorawan scenario that demonstrated we could have live data coming off these sensors into the Lorawan network, which opens up the whole concept of their probe being deployed in, field-size scenarios, because these probes are now really inexpensive, whereas before they were hugely priced. So some great things. Now, the latest developments as of end of March. Norfolk and Suffolk. Norfolk were really good in terms of picking the ball up, working with us. They hadn't outsourced their IT infrastructure. So they had an infrastructure team in the county council. And when I went to them and proposed all this LoRaWAN stuff and demonstrated it to them, that team kind of lit up, because all of a sudden they could see themselves being more than just the wired grid and the fiber grid. Now they could be a wireless telco as well. And they started just doing the work, the very simple work, to be able to create, a secure, safe lines in their network to be able to hang their gateways off. And they've got a portfolio of 600 buildings in Norfolk, which they could go around and hang these various gateways off straightforwardly, already on their fiber backhaul, which meant that there was tremendous opportunity. But they also went to Suffolk, and they spoke to Suffolk, and the pair of them put in a funding bid to the new East Anglian LEP, and basically they got that funding. So we now have funding for the deployment of enough gateways to, with a goal of covering the full 8,000 kilometers square of Norfolk and Suffolk, which is a pretty substantial network deployment in its own right. What's interesting is that their focus for the justification was on skills and jobs and innovation, not actually on their own services, but the opportunity not only of bringing wealth into the county for people doing those sorts of tests I described and innovation, but the opportunity for startups and individuals to build technologies that they could then take commercially. And then we'll see actually those benefits that I wanted to see at the start of it into the actual county councils. One of the communities, my community's startups is Uniotech. These guys have been working across the winter because when we started speaking to the council, we found a number of really interesting scenarios that are just, sinkholes for money. And we felt if we could help them in those, we're going to save money. So how much do you think Norfolk County Council spends on spreading grit every year? You can't answer, Mark. Any ideas? Anyone want to guess?
20 million.
500,000. I think there was a 20 million. 1 million? What did you say, sir? 1 million? Yeah, well, 4.4 million pounds throwing rock salt on the road, right? And it's approximately 40,000 pounds a gritting run, which they might have to do twice in a night, depending on what the weather conditions are. So what we started to do, or what Uniotech started to do was, one of the scenarios was literally, let's embed some sensors in road surfaces, tarmac surfaces, and capture the real road surface temperature. Because there's only half a dozen or so weather stations that Norfolk County Council use to gather real weather data around across the county, and they're all measuring air temperature, not the temperature in the tarmac. So these guys very simply started deploying devices very quickly, no problems in setting the dashboard up or getting the data flow through. The network was already there because they just rocked up with their battery-powered sensors, a couple of AA's, powering these devices. Very inexpensive, waterproof thermometer sensors that we've got buried in the tarmac. And now they're already sort of, looking at that live data against the forecast data or the air temperature data and realizing they can be more precise in the deployment of their gritting, which is going to save money directly. And what also came out of this is that we had a new road built across the north of Norwich, the Northern Distributor Ring Road as it's called, the NDR. And we discovered that the council had actually been relatively forward-thinking in that they had embedded thermal couples, which are thermometer devices, into the road surface or into this road already. But they hadn't got them connected to anything. So these guys are running around just building the device and plugging it into the cable, and hey presto, we've now got a fully instrumented road. So if you're familiar with the M3 and its smart highway update, we're not lasting 6 months or 7 or 8 months or whatever it is. There was some forward thinking. That road is now being instrumented in a variety of different ways, and really just provided by the Lorawan gateway. And I realise I haven't said, but a commercial Lorawan gateway can be as inexpensive as £150 for an indoor one that sort of is the same sort of style as your Wi-Fi access point. But it goes all the way up to maybe £900 to £1,000 for the sort of IP67 aluminium cast case that can sit on a carrier's mast and survive any weather you want to throw at it. Okay, and Norfolk County Council have been deploying mainly IP67s, but also some of the more industrial type, this one, which goes for about £300-ish, and is, as you can see, pretty robust. So you can stick it in a factory site or an office location or something like that. So, it's hugely inexpensive for the volume of data they're now getting and the ability for its contribution in savings. As I said, there's a lot of things going on. We established a collaboration with Hull because Hull had done the opposite to us. They paid for a company to deploy some TTN network gateways and try and establish just the network. But what those guys didn't do was establish a community. So as soon as the money had been spent, the company walked off the plot, and Hull City Council was left with a couple of gateways that they didn't really have anybody utilising. So they started again last year with an ambition to build a community, which they're now getting going, based around an accelerator in Hull, C4DI, which is actually a hardware accelerator as opposed to a software accelerator. They've built now a community of air quality devices. At the moment, their devices are mainly Wi-Fi based, running at people's homes, but they're now moving on with having signed a commercial contract with a new organization that's running out a LoRaWAN network more uniformly and deploying some air quality sensors. And what's interesting from Hull's perspective is that they are downwind from Scunthorpe Steelworks, which probably is as bad as it sounds, basically. They have a lot of pollution that blows in, or they think they do. But they also have a high level of road congestion. So this data is directly helping them identify whether it's pollution they can't do anything about, or it's homegrown pollution that they could do something about. So, without this sort of stuff, that there needs to be that there is not the insight to do it. Just an aside on air quality, Norfolk, or Norwich's, one of Norwich's locations for its European standard air quality sensor that causes a fine of quite a lot of money, is actually based in an odd area of the city, which has become the de facto bus station. It's not the bus station, but it is the street where all the buses pull up and stop for 5 minutes with their engines running. So it's not surprising we got hit with poor air quality. It's not representative, but with only 2 or 3 actual locations that are receiving air quality data, you can't tell that without local context, and we don't know the broader story. So having this community-based air quality movement from the whole's perspective is really providing them with new data, and they've got about 20 or so devices coming out. So no matter where you are, the point is there is probably a TTN community starting up or running. You can start your own one. This is a great shot from the top of another accelerator that Mark and I have been with. Mark led the way with instrumenting a commercial farm with various Lorawan stuff. And I had the opportunity to provide a multi-tech gateway, one of these IP67 gateways to this innovation center. And this is based on the Isle of Anglesey. And it's incredible because we're seeing sort of 30-kilometer, like we have from the same device in Norfolk, but 30-kilometer kind of reach of this device. And when you look from this location back to the mainland, so actually the opposite direction, I think, to where this picture's taken, it actually is into Snowdonia and into, or you could, in theory, see one of the first locations, or the first location of Marconi's first long-wave transmission. So I kind of have a little fingers crossed that we will actually have radio coverage back to that location. And the concept of an Australian rocking up to Anglesey and turning on his TTN sort of device, forgetting for a moment that there's a change of frequency between Asia and Europe, but actually then having his app in Australia receive the data that's been collected locally and flown through the TTN network is quite exciting because Marconi's first long-wave transmission, I think I'm right in saying, went from this area of Snowdonia round to Australia. So, we would have done it in a homebrew kind of way. So really is an opportunity to get going. The projects we're working on, as I've mentioned, is air quality. Some of the other ones are interesting. High-street bin monitoring is actually really simple. The devices are pretty simple to actually do. But again, it's an impact on the amount of money that's spent emptying bins, which also has an impact on how we like our city streets or the tourist areas of Norfolk, where the old fish and chip shop contributes to the bins being full a lot of the time. There are some other interesting things. Our libraries are funded based on an estimate of the people they serve, but the actual calculation is based on people attending the library. So if we had reliable people counting, that's an interesting, it could be a positive, could be a negative, but it would give them some data. And the car park space one, this is interesting. Now, you probably think, well, hang on a minute, we already count cars. We can see it on the road sign as we approach these things. What's the point of this? Well, this is interesting because, yes, we do in the multi-stories, but in the street-lined and the smaller car parks, we don't. And the idea is that these devices, can not only, populate and instrument those street-side parking, but there's a much bigger opportunity here. And it's not giving us drivers information. It's actually about changing our habits. Because the potential is that we could see council-owned car parks deliver demand-level pricing for car parking spaces, which would dissuade us driving in. But it also gives them the opportunity to do something more positive, and that is, Norwich has got an outer ring road with lots of park and ride things on them, but we drive past like this and ignore them. But the potential for Norfolk County Council to go, hey, there's a discount because the city centre's full. There's a discount on the park and ride now. You go there instead, and you'll pay less, and you won't have to wait 20 minutes or sit with your engine on for 30 minutes or drive around 30 minutes waiting for a car park space. What's also interesting is that the infrastructure team at Norfolk County Council have got a microwave network controlling their traffic lights. So as the head of IT said, there's real an opportunity that if we see you speeding, we'll just make the next set of traffic lights red, right? Slow you down. So there's also this opportunity of being more reactive. Do we want to, flow the traffic out of the city? Do we want to direct the traffic away from the city centre because it's full and car parking? There's this interesting idea of moving that forward. So when we talk about the maturity model for IoT, 0 is no devices, 1 is sort of getting some devices connected, 2 is achieving some sort of information system, and 3, 4, and 5 is really where we start to innovate beyond that. This is in that space of innovation. If I am a parking warden and I get information that says these 3 parking meters or parking spaces are about to run out, I can target my ticketing. Just 2 tickets will pay for one of those devices. After that, they're free, and they could change the whole dynamic and habits of drivers. So that's the sort of scale of thinking we're on. And then you look at things like where we're going. So again, I've already mentioned some of those small devices, but this is this is actually a module that hosts one of the newest generation of processors, the R34, which is a Lorawan and a MCU, all in one box. But even this one that hosts all the passive components you need to run it as a LoRaWAN node is only 11.5 millimeters square, right? Technically, same sort of size as a 1-cent coin. Okay, and that's potentially your compute power and your radio, depending on what sort of sensor you're going to connect to it. And then you start looking at other things that we're seeing. And this is this evolution of crossover processors. This is the long wave of the Moore's law. So in our CPU world, our MPU world on our PCs, we've seen fabrication techniques go from the 90 nanometer all the way down to 5 nanometer transistor, thank you, transistor manufacturing, right? But as you descend there, not only do you get smaller devices, but your power consumption drops considerably. So we're seeing this great evolution of those fabrication techniques coming to our MCUs. And in those MCUs, we're seeing radio chips being integrated, we're seeing everything getting smaller, and we're seeing the power getting cheaper. And that just means that we're ending up with more compute capability down in these small devices. And it's enabling us to play with all sorts of things. The Dementia Buddy thing I've spoken about, and if I just play with my system a bit, and then jump up here, I just wanted to show you this. So let's just bring this up here. So I don't suspect that many of you can see this, but there's a little payload there, which is a couple of MAC addresses and associated with them the RSSI values. That all comes from my prototype, which I built yonks ago but haven't done any more with yet. That's an urban tracker. It's got a LoRaWAN radio on it and a ESP8266. So altogether, buying from China, that is less than £10 worth of effort, okay? And there's a little battery in the middle of it, which means if I plug it in, we'll see whether what we get. But we should, in theory, see, oh, there we go. It made a network. It's done a reading. And if I refresh this map, this might move or it might stay. But you'll notice that this is, in fact, the reactor. And just by sniffing the data, I'm running a little Node.js app here on my PC, which has received the data via the Things network. And it's now plotting, doing a reverse geocode lookup using Google's API on those MAC addresses and RSSI values. And it's placed us there, which is accurate. Okay? So this is what I want to then miniaturize, because miniaturizing that leads to this idea of a county-wide, at least in Norfolk, dementia tracker. So we're seeing a growing number of people living with dementia. The idea that they can have a device that runs for multiple years, sort of salted away on their pockets, handbags, hat rims, walking sticks, whatever, and it just sits there. And if they go missing, the people caring for them can put a message in the network that says, next time the device chimes in with a heartbeat, ask it to give a location. And then we can find these people. And we already know that our emergency services and various volunteer groups spend, nights, days sometimes looking for people. And sometimes, unfortunately, they don't find them in time. And so this is one of those great ideas that says, you know what? A countrywide or a citywide, a countywide, a countrywide network where this device can just come alive with an authorized message, and these people could be found, within minutes. Because a device can sit there and it can be hibernating and just wake up in minutes to give a heartbeat and then receive the message that says, we need to know where you are. And from that moment onwards, it can just, I'm burning the battery. I'm just going to tell you where I am every 30 seconds so you can come find me, right? And that suddenly is one of those powerful stories that really motivates me in terms of the impact that we can have. Cool. And then we've got, this other idea, the care tracker. The idea that actually the sensor on this thing is an RFID reader. They're inexpensive. Again, they cost a couple of quid. So then you have a device at home where, quite literally, the care worker takes their badge, they tap in and they tap out. And us, as responsible adults for the individual receiving care, know that that care has been delivered and we know it's been delivered in an appropriate time. Yeah, none of that problem. Okay. This is just the little thing I was telling you about. I went to Hull, never been to Hull before, turned my device on, a couple of TTN gateways, woohoo! I was correctly located in the device. This is another one which is really interesting. This is a completely different device. It's an OpenMV M7. It's a little camera and processor. It's about the size of a small box of matches, right? But in the latest rev of this, the OpenMV H7, it uses a new version of the Cortex M7 chip, which has been manufactured at 40 nanometers. That means it has quite a significant power reduction. And the manufacturer actually estimates that this device could run with a 1-minute activation on a 1 amp hour battery for longer than a year. Now, what's that? Why is that relevant? Well, with this library, the Sensors NN, the Sensors Neural Network Library, it's optimized for the Cortex M series of processors. It enables us to run small neural network models on this device. And this device's current sort of thing is a CNN, which basically enables you to do your mobile net identification of a number of different classes of image. On a device the size of a small box of matches, it runs on a battery for potentially more than a year. Okay? So the concept of being able to move forward with these technologies is quite exciting. How many people have seen the Google Coral just came out? Yeah, well, Google Coral is like the neural compute stick from Movidius and Intel, but this actually outperforms, it's 2 years afterwards, but it outperforms them by the Movidius stick by something like 13, 14 times. So whereas a Movidius stick can do 10 frames per second on my Pi, this thing can do 140 frames per second, running a model, a TensorFlow-like model on it. But what's interesting there is that when Google announced that, they also had this little side thing, because they've got an experimental branch of TensorFlow Lite, which can run on a Cortex M processor. This is a Cortex M4F, so it's got floating point. It's that little chip there. The rest of it is fun things. So you've got an accelerometer and you've got 2 microphones, MEMS microphones, so you've got a microphone array. It ships with a very simple yes-no keyword speech recognition model and flashes a different LED at you when you say yes or no. It works better on yes, to be honest with you at the moment, but it's still in development, so not to worry. If you ever see me demo it, I'm going to go yes. I'm not going to say no. But anyway, the whole point is this, again, this fabrication technology coming down means that we're seeing things like that chip is an Apollo 3, which is a manufacturer's particular implementation of the Cortex M4. But it has 6 microamps per megahertz in the processor power usage. It's nothing. It can last for ages on. In fact, that whole board, if I could turn it around, you'll see a CR2032 coin cell battery on the back. That's what will power it. And it only powers it for days in this instance, but nonetheless, you can see how low the power requirement's going, yet this thing's running a TensorFlow Lite model, yeah? Which is interesting. Of course, they're small models, only K, but it's actually manufactured with 1 megabyte of flash and 384K of storage, which is a lot for an MCU, because it's an MCU targeted at running these sorts of models. Right. And what are we doing with them? Well, here's one thing that I've been working on. From CMU, Carnegie Mellon University, I followed up on a water utilization circuit, which basically uses a piezoelectric sensor to detect vibrations in your tap, so you know when the water's turned on and off. But my ambition is to add it to the water inlet pipe on a house. Because if I can build a routine of water utilization in the house unobtrusively on a device that runs on batteries, then I can add it to my mum's place and I'll know when she gets up and does the early morning flush or the kettle fill, or actually has rather too many flushes during the night. Any of those, too many flushes or no flush at all is an indication that she's potentially not well, which will just give me the nudge to give her a call. This idea, the Home Alone Guardian, comes from this just concept. Even if you're a young person living alone, the question, who will come if you have an accident, is a pertinent one, and one that causes anxiety. And this is an example of where, do you know what? If you could sell this device for less than £50, and the backhaul is there because it's LoRaWAN, you have a device that says to you, we know your relatives, parents, friends are okay. Or within minutes, And it might be 10 minutes, this isn't a critical life solution, but within 10, 15 minutes, we know that something's wrong. Yeah? And then you get the nudge, the text message, the email, whatever, that is just the normal notifications channel to react. Okay, so, wow, that was a load of things. Let me tell you how it connects to Azure. Sorry, I can talk about this for days. There's more food, we can survive. No, very quickly, let's have a quick summary of different ways in which we can connect this thing to Azure. So I've been writing code for multi-text devices, the IP67 and this thing, for a couple of years now. These are interesting because certainly in the early days, they had a Lorawan server that could run directly on them. That's now a feature that's happening across more gateways, but in the early days, these were one of the few that had it, if not the only ones. And that meant that I could just place this anywhere in a building, and if I could connect it to Azure, then, hey, I've got an instant Lorawan campus deployment that could instrument this building, this site, this street because of the coverage. So what I did was I just wrote a IoT hub client that integrated into Lorawan server on here. And it receives, obviously, the data from the packet forwarder, from the Lorawan server that says, oh, I've received these sensor packets, and it forwards them on as telemetry data to IoT Hub. But in the other direction, it receives direct method calls, which means that we can reset the whitelist on here, we can update the whitelist on what devices it's actually going to listen for. We can send downlink messages via direct messages, which downlink messages are the ones that you want to send infrequently in LoRaWAN, but they go down to reconfigure the device. So if you wanted your device to poll more often or less often, you could configure it to receive a downlink message which configured that parameter. So that was a fairly easy thing. This is an open source project, that my code anyway, which is out and available, and it's now a much simpler monolithic C implementation. It was originally a IoT Edge v1, but people didn't like the smell of that, so I made it simpler. So that's all cool. But we've also, the group I'm in, Commercial Software Engineering, have been on LoRaWAN, and we've built ourselves a .NET Core, .NET Standard 2 LoRaWAN module for IoT Edge v2. So you can take anything that runs IoT Edge v2, whether that's a Linux box or a Windows box, and in one of the modules you can deploy a LoRaWAN LoRaWAN module, sorry, that will interface into your Raspberry Pi board or commercial gateway. And there you've got exactly the same as what we've said here, but now it could run, you know, whatever. It can be offline for multiple hours and do store and forward. It could do multiple or sensor stream analytics, so you could add more modules to do different analytics and cause different things, and then it could also deliver that data to the cloud. That, again, is an open source project on azure.com/Azure, and it's the IoT Edge LoRaWAN starter kit, and we've just released version 1 of that. And it just means that you know, you've already got the skills to add to it, to extend it, to see how it's working, to take ownership of it, to contribute. Yeah? What is IoT Edge v2? Good question. So IoT Edge v2 is a software solution for managed container deployment onto a edge computing device. So in IoT Hub, I can specify a manifest that says these modules that exist in some container registry somewhere, which are linked, I want deployed on this device, and I want to structure communications between these modules in a particular way. So when my data receiving, such as the IoT Edge, such as the LoRaWAN module receives some message, it might route to the next item, or it might route to a different module, and that module might route back to another one. So you can basically define the whole routing of the messages in that line. But ultimately, it's a very simple configuration in IoT Hub, which is a JSON manifest which says, say again, sorry? It's built on device twin. Each one of these items has a module twin, which sets its configuration, and this essentially has an IoT Hub manifest, which is what you might call device twin associated with it. Yeah. So it builds on that whole mechanism. So a very simple data definition, targeting a device that's got the IoT Edge runtime on, and what you've asked for will be there very quickly. So you can run up ML modules that do different analysis on things. Okay, I've been doing a bit of cruise ship work where we're watching lines of people in cruise ships, so we can work out automatically where the queues are forming and so on across all these massive cruise liners, things like that, all running on IoT Edge pieces. There's the AI vision dev kit, which is a Qualcomm-based NN accelerated hardware which runs IoT Edge. So you've got a little camera that has battery so it can run by itself, and it runs this sort of stack of modules to do analytics on the video feed that it finds. So that's available for you. This is me playing with Azure Sphere. So I've been running Azure Sphere code for quite a while. So after 20 odd years of being Microsoft, I spend my life writing Linux software now. But basically, Azure Sphere is this hardware environment, a chip. It's just literally just, you know, this chip here, as it were, which contains multiple cores, hardware firewalling, software firewalling. It's got a Cortex-A processor in it and a couple of Cortex-M4Fs that deal with the GPIO in real time. And you write an application that essentially runs in a sandbox here. And then you've got the security system that manages this environment and ensures that we deliver via the Azure Sphere security service all your image updates and everything else to the device for a 10-year period when you've bought the chip. This is the big dev board. And that's an IC880A, which I'm just doing the porting of the gateway and the packet forwarder software for Sphere. So this Sphere will be able to be a Lorawan gateway running against that board. This is the actual MCU that's just becoming available. That in real size is not bigger than 25 mil. No, 25 mil is too big. It's less than 20 mil square. That's a RJ45 Ethernet board that can be plumbed into things. That's a smaller dev board. So, you know, those sorts of things are coming out. There's a whole secure environment. This just to give you a picture of network services. So we've got our sensing devices, we have our gateways that are deployed, and then we've got our LoRaWAN cloud service. In our instance, it's the Things network that we're utilizing, but there are other commercial services that are available. And this, what is interesting, is that this could also be your own private instance, as could these, which are actually your application services. So at the back end here, you have an application handler that is the thing that receives your data and actually knows the key that was used to encrypt your data. So your data is secure from there all the way, in theory, to at least this point, if not to here, depending on what that application server is. And if I looked at the Things Networks implementation in V2, you know, we have these gateways that are running packet forwarders connecting to this bridge and this router that has this network, this message broker which sends to the network service and does all the validation of the network messages in terms of man-in-the-middle security and things like that. A discovery service of all those different services, because obviously these all scale out. And then you have these application handlers that present various API mechanisms that you can write to. And when you can look at this, and this is why this is really interesting from my perspective, you could have a public things network, which is all of these things scaled out, and you can take your application handler and you can run it in your own space. And that means you potentially own your keys, and therefore your data might originate via a device prior to the gateway, but it traverses the entire things network entirely encrypted until it gets to your application handler. Then you decrypt it. And then you've got your payload data. And then there are also network security session keys that are used to establish a communication that's secure to the network services, so it's authenticated and your data remains encrypted all the way through to that point. The second box here is just to demonstrate that because the Things Network software is all open source, you can take all of it and run it in your own private location, whether it's on-premise or in the cloud. And you own a Things Network then. Yeah? And so you own your key, your joining service and your key server, and everything is under your control in terms of quality of service and things. But at the same time, you know, you can take aspects of this, you know, like the application handler, still use the public network, but put that application handler in your own space so you've got your contained security that actually works through. And version 3 is now being released. It's still in the early days. It's got a CLI as opposed to a web front end for you to work with, but it does all the core stuff. It's written in Go and Node for the front end stuff, so if you're into the Golang, you can go explore how they've written an entire LoRaWAN network stack for that. And it's got a Docker Compose YAML out there, so you can just throw it up on your own machine or in a VM on Azure or whatever, and you've got your own instance of the Things network. You can add a gateway to it, you can add a sensor to the network, and then you've got your own private instantaneous network of LoRaWAN for you to run from the cloud, and then your gateways for whatever their backhaul can do all of that. So, you know, the Things network gives us this tremendous flexibility. And then if you want to actually provide an application handler, you can start very simply from an Azure perspective, because the Things Network app handler has both an HTTP webhook or an MQTT endpoint. So it's really easy. I use the Case Online MQTT extension for Functions v2. And that basically means I give it the security certificate that the Things Network utilizes, and the access key, etc., for my endpoint. It listens, delivers to my trigger where I pull out the key pieces I want for my partition and row ID, and then for the actual payload packet, I actually write it to Azure table storage because I wanted this whole thing to cost pence. And then you can have a web API that just pulls the data, queries it out of table storage, and does the other manipulation to present it. I mean, that's as simple as it could get almost, although I could just have a webhook rather than the MQTT. And that's exactly what the IoT Central Bridge does. So this is a Microsoft Corp open source project, and it provides you with the ability to stream your Things Network sensor data directly into IoT Central, where you can construct these styles of dashboards, and is the kickoff point for orchestrating workflows, into archiving into Azure table storage or other storage mechanisms. You can have eventing that's gathered in here and actions that actually want to be triggered. The dashboard can have actions that you can cause to happen. It has the idea of jobs, so you can actually fire jobs towards a subsection of your devices to do that downlink message, for example. So you can create your dashboards, and then quite literally, I hadn't played with this, but it comes up in 5 minutes, basically. Very little linkage that you need to do to make it all work. They've got an ARM template, so you press deploy, and it builds it out for you, and basically adds a key server to your Azure subscription to facilitate all this from, and then uses the function again with a webhook. So it's fairly straightforward to actually do. But then you can, point and click and draggy droppy and create your whole dashboard with actions and functions for your sensor population with really no effort at all. So you'll be pleased to know I'm going to wrap up. Getting started, it's really easy to get started, and if you haven't got a TTN community in and around you, do start looking to see whether, there are interested people around you to start with. You can get going really quickly, as I've mentioned. The current prices for that board that 2 years ago only cost us a tenner, unfortunately now cost us about £18 with an FTDI programming board that's required. If you've already got this, then you can add, delete £3 or £4 off that price. And then you've got these sort of plug-in gateways. I've only got one with a European plug, but basically, that is a TTN indoor gateway, and you set it up to run on your Wi-Fi, plug it in, and you can get it from RS for £75, including that. So, it's fairly inexpensive to get going. And there are loads of how-tos, etc., as I've sort of indicated on the Things Network. And you may or may not be interested in the Norfolk and Suffolk TTN groups, but there will be TTN groups around you, usually advertised on meetup.com, so you might be interested in taking a look in those. Right, gosh, ran on for ages. Had some code to show, don't need to show that. What else did I have that I might have shown? Just the how to get started. It's all documented, good old Olivier, documenting up how to do everything from the IoT Edge Bridge perspective. And if I jump to another one, I can go to the Things Network console. And this is, just an example. This is this box. If I turn this on, in theory, we'll start to see some new items. There you go. So I reset the frame counter on here. So this isn't safe in terms of man-in-the-middle replication, but that's 0's turned up already. So this is my browser into the Things Network. It's already received the first opening message from here, and it will continue to receive it. And that data could have flowed straight through to my IoT Central dashboard, for example, just at that point. This is me looking out at a particular application where I've got 40 devices registered in that one. These are all the various applications that I've got going in various things. So I could go down and look at some of the humidity devices that are across my, my home. And at the same time, I can go to gateways, and we can have a look at some of these gateways that I've got distributed now, not only across Norfolk, but across different parts of the country. And And you know, some of them are connected, some of them are disconnected because there are Raspberry Pi ones that have been swapped out for proper things now. But yeah, a whole variety of different devices that you can go see. And when you step into them, you know, you can actually go and watch the traffic that's going to run across them. And most of my devices are on 5-10 minute intervals, so we may or may not see anything there. But that's the sort of TTN environment that enables you to just work through and see data. Okay. Oh yeah, another question.
Sorry, just a quick question. How you switch on the device and it picks up the process transmitting?
Yep, it's a broadcast approach on a Class A device. So your device will start shouting whether there's anything there to listen, and unless you've asked for an acknowledgement, you won't know that, or it won't know that nobody's listening.
Okay, and there are antennas in the areas, or did you bring one just up?
No, I turned this on and boof, hey presto, something turned up, something's just turned up at home, and you know, that was it. And I can go to TTN Mapper, and I can have a look, so ttnmapper.org, and there you go, that's sunny Norfolk as it currently is. And if I come down into here, you can see actually there's quite a lot of devices, or quite a lot of gateways that are in and around this area. We must be under here somewhere, wherever. Anyway, Houston Road, we've got to go the other way, haven't we? Right, that way?
Yep.
Thank you.
Slightly down.
Holborn. Don't know, can't see it, but anyway, that's an example. It's pretty good coverage anyway. So yeah, you know, you can have a look on here, and as soon as you put a gateway up that's you know, got a public location, because you don't have to publish your location details, but if you do, it'll pop up on here and you'll see where your coverage is extending based on walking around with one of these and the phone app running on your device. Yeah.
Quick question on the gateway. So the store data from all sorts of devices that goes to the backend application. Do you use 3G for it?
So all the gateways require some sort of backhaul. And that backhaul to date has been typically wired, because we've used either as a community member, you've connected to your own broadband, or as in our case, the county council has got its own distributed fiber and wire network, which they've been able to attach their gateways to. But you can buy, so that big IP67 that was out on that view on Anglesey, it does actually have an LTE capability in it, although it's hardwired. So you can use LTE backhaul. In fact, one of the really great innovations that's happened this year is a UK space company, Lacuna Space, has actually got its first satellite up, launched at the end of last month. And they're doing a Lorawan going to be from a constellation of little CubeSats that will travel around, and you have a special antenna that's pointing straight up as opposed to the normal horizontal. And you'll be able to send your data via a satellite down to the Things network and receive your data in the same fashion. So you don't even need a gateway. And there's another Australian company called Fleet.space, and they have solar-powered gateways that use the more traditional Inmarsat backhaul. They are planning to put their own satellite constellation up to have their own backhaul. But so in the same way, you need to have a backhaul. But also we're exploring and playing in sunny Norfolk, where there's lots of agriculture. This idea of a baton device, where the gateway is basically store and forward device. Farm vehicle drives by with something on it, which communicates, exchanges some data, and when the farm vehicle ends up in the farmyard, it goes up on the local, broadband. So there are many different ways to achieve your backhaul, but yes, they all need a backhaul of some sort.
I was going to ask about that. It said on the Things Network web application there that was the community edition.
Yeah.
Is there a commercial offering by them? And have companies actually sort of grown up with the Things Network and are now actually making money from products?
Well, so I think there are several things there, and Mark might like to chime in as well, as he runs a company that is making use of the Things Network and so on. So we've seen a growth in actual end sensor devices for LoRaWAN, and many of them are in the portfolio, for the Things Network. The Things Network guys do have a commercial entity they call the Things Industries, and they manufacture and sell various gateways. as well as offer a commercial level service, which you would pay for. Do you want to add anything, Mark, to that answer?
There's a couple of companies that spring to mind who have been born of things networks, like, and in Henley, there's a company called CoolZone, deals primarily with monitoring fridges in commercial properties. Am I not speaking loud?
Yeah, I just want to make sure everyone's got on the feed, so just give you a mic.
That better? Okay. Yeah, there's a company in Henley called CoolZone who has, they primarily monitor fridges for pharmaceuticals and for food companies, restaurants and things like that. So where there's a compliance need to keep track of the temperature of the fridges. And they have built their business on the back of the Things network, so they use that as the backhaul. And they've grown very well over the last couple of years. And then in Australia, there's a company called Meshed IoT, and their business is to supply and deploy a Things network. So they actually deploy the gateways. So the other end, whereas CoolZone deals with the end devices and some gateways, but on a more private instance, Meshed is deploying Lorawan networks for councils across Australia. And so their whole business is based on the Things network.
So let me just wrap up and say, you can get started for very little. It's a great place for innovation. The actual impact from a tech for good scenario is phenomenal because most of the councils are still at this place where they're just starting. They may be just deploying the network. They're still looking for solutions. Adult social services is absolutely bang on target for almost all of them. Well, all of them, basically, because they all suffer the same financial challenge. So, this is a great point of intersection for us, I think. We've got the connectivity, we've got the hardware, we certainly have the software skills. We need to come together and build out some great ideas. There's definitely commercial solutions there. But in my community, there's a, hey, I've got a day job, I don't want to do that. So what we've done is we've actually produced a bill of materials for solutions we've created so we can educate the county council. So they say, okay, look, we ran this with you. You know it works and what limitations it has. This is all the parts that came up, how much it costs. Now you could have maybe a more sensible and informed conversation with suppliers. Because as with all new technology, there's a hyped price. And we have seen that price descend quite quickly in Lorawan world, but it can go further. And so, I see this very much as a, citizen innovation where we are looking at the challenges, that the county councils can offer us that we see that others from rural or agriculture come to us, we can see. We can demonstrate things. Small groups have started businesses around this whole thing, but at the very least, we can demonstrate a solution that inspires others or gives the councils the opportunity to have commercial conversations where they're informed. And they haven't had to spend money for it. I mean, it's worth noting that Norfolk are now establishing a materials fund. Only a few £100 per project, but they will pay for the materials for us to try ideas from. Because from that is small pence, and the potential opportunity to come out with a game-changing solution that will save them, literally hundreds of thousands of pounds. I don't know if I mentioned it, but Hull City Council, they pay £100,000 a year for the mobile speeding signs that tell you to slow down and flash at you. £100,000 to move those signs around the city. And of course, as soon as they move them, they've lost any data in terms of whether they've had any long-term effect on driver behavior and things like that. They're only point-in-time data sets. And we've sort of just envisioned with them and said, well, you know what? We could instrument 5,000 street lamps, let's say, for a 1 year's budget, and you'd have a 24/7 traffic monitoring, not speed traps, because we're not doing that, in terms of our capability, but we can count cars and lorries and things like that. We can count throughput. We can estimate speed as well. And we could also add air particle sensor. And that means that you'll have 24/7 traffic and air quality, not necessarily noxious gases, but, certainly the particle count, which, gives you a lot more information across the entirety of the city, for 1 year's budget. And it's a game changer in that context, because that £100,000 goes off to spend on something else, afterwards. So, and we haven't even really open the door on adult social services. We know it costs councils in the region of £1 million a day for delivering adult social care services. Yeah? So the idea of an urban tracker or a home alone guardian kind of concept, it could really save a lot of money. You know, the optimization, the care worker tracking sort of thing that just says, yes, a service happened at the right intervals, or at least give us the data where we can do the analysis and say, the outcome of this care isn't great. You know, what's happening? Aha, they're arriving early. You know, those sorts of scenarios. That's all still to be played for. So great opportunities for us, you know, to actually come forward independent of carrier commercial models and actually, you know, help society, have societal impact. I mean, that's what really excites me. And I hope I've given you an inkling of that and some ideas that you could actually start playing with at home today and then go forward. So thank you very much for having me.